So let's take a look at some of the trickier examples that you might come across when you're finding horizontal asymptotes. So I want to find the limit of the function 3x minus 2 divided by radical 2x squared plus 1, and I want to find it towards infinity and towards negative infinity. Since x equals the square root of x squared, and x equals the negative square root of x squared, we will use the first as we approach positive infinity and the latter as we approach negative infinity. So that's what I mean when I'm talking about this guy or this guy. So if I take the square root of x squared, essentially what I'm saying is I'll get plus or minus x, and so that's what I'm going to be doing down at the bottom. So let's take a look at our example. I am taking everything divided by x. So 3x divided by x, 2 divided by x, and all of this. I want to divide it by x, except I really need it to be inside of that radical, and that's why I chose the square root of x squared, which is x. So this guy gives me 3, this guy gives me 2 over x, and then inside here I'm just going to do some reduction as well, which gave me the 2 and the 1 over x squared all inside the square root. Now we need to find the limit of this guy. So the limit of 3 is 3, the limit of 2 divided by infinity is 0, and the limit of 2 is 2, and the limit of 1 divided by infinity is 0. So I get 3 over radical 2 as I move to the right. As I move to the left, I'm going to do the exact same thing. I'm dividing everything here divided by x, but here, because I'm coming from the left, I'm taking the negative square root of x squared. So this turns into 3, this turns into 2 over x, just as before. The only thing different is my denominator. I'm going to have my negative guy on the outside, but really, as you can see, it's the exact same thing. I'm just going to end up with negative 3/2 instead. So again, that's a trickier example because you wouldn't automatically think to divide by x, the square root of x squared and the square root of negative x squared. Let's take a look at another tricky one. This one is dealing with a radical function. And in a radical function, hopefully you recall from when you learned this previously, we need to look at the conjugate. Conjugate being change the sign, multiply it by exactly this, but the opposite sign. So I'm going to, sorry, not opposite sign, opposite operation. So notice here I've got 3x plus radical 9x squared minus x, and I'm multiplying top and bottom by the conjugate of this, which means I wrote it exactly the same, but I wrote a minus instead of a plus. Now, the advantage here is that even though it's going to start to look uglier, because let's face it, it didn't look that ugly to begin with, but if I were to try to plug in infinity right away, I wouldn't be able to find a solution, which is why we have to do this tricky way. So the bottom is very easy because I just get the conjugate. For my numerator, I'm going to get 9x squared, and then I get minus 3x times all of that, and then plus 3x times all of that. So those two things cancel out. And then I just get 9x squared minus x times 9x squared minus x. So basically they were inside the square root, and I'm squaring it, so I got that same value on the outside of the radical. And then again, it's just algebra. I'm just combining what I can. These two guys combine. This turns it into a positive x. My denominator, I didn't do anything to. And I still can't do it because if I tried to plug in negative infinity or infinity now, it still wouldn't work. So I went back to that trick where I said, hey, let's divide by x. So I took everything divided by x. And again, because I had negative infinity, I put negative square root of x squared. This guy turns into 1. This guy turns into 3. This guy reduces and gives me 9 minus 1 over x. And then, of course, at this point, I'm actually able to find the limit because the only thing I'm really finding the limit of is that one. So it's 1 over 3 plus the square root of 9 minus 0, or 1 over 3 plus 3, which is 1/6. So my horizontal asymptote would be y equals 1/6. My limit would be 1/6. Now let's take a look at another tricky example. Again, one that you wouldn't probably just come up with on your own. So previously, I had given you a property and I said, guess what? If you're trying to take the limit as x approaches infinity of sine of x over x, you're going to get an answer of 0. I just gave it to you as a fact and assume you took my word for it. Well, this is a way for us to show that that is in fact true. And it's again using something that we have also learned previously called the squeeze theorem. So let's go through it step by step. I know if I were just looking at sine, I would not have a limit as I approached infinity, because this guy is the sine function and it just oscillates. It goes back and forth between -1 and 1. So notice what I've done here. This is what I'm trying to get to. So I'm starting with what I know. Sine oscillates between -1 and 1, inclusive. So what if I took everything divided by x? Well, then I would have -1 over x, sine of x over x, and then positive 1 over x. Well, now what if I took the limit of everything? So the limit of this guy, 0, and the limit of this guy, 0, and this I don't know, but guess what? That's what I'm trying to find. Well, if I know that the limit is between 0 and 0, then my limit must be 0. One more tricky one, really similar to that. Let's say I'm trying to find the limit of x minus cosine over x as I approach infinity. So I'm still going to use my super cool, fun trick where I take everything divided by x, because this guy now turns into 1, and this guy turns into 1. And then I have cosine of x over x, and I don't know anything about that. So again, notice that cosine oscillates between -1 and 1. And then just like I did with my sine function, let's take everything divided by x. Let's take the limit of everything. And the limit has to be between 0 and 0, which means this limit must also be 0. So 1 minus 0 over 1, my answer is 1.